how to look at your answer and decide if it makes sense. In general, there are some things to look out for depending on if your unknown is grams, or if your unknown is atoms, or if your unknown is moles. So in general, grams, make sure your calculation included a mass from the periodic table. Gosh dang it, I forgot to take my highlighter off. There we go, mass from the periodic table. Okay. Your answer could be any number between 0 and about like 600. Grams can have a decimal and can have a negative exponent. I mean that in scientific notation, so it's allowed to be 10 to the negative something. The answer is usually going to be under 100, usually between 0 and 100. It's possible for it to be a bigger amount of grams though, like easily. For atoms, make sure that your calculation included Avogadro's number, 6.02 times 10 to the 23rd. If you left that out, then you're definitely doing something wrong when your unknown is atoms. The answer should be in scientific notation if you're solving for atoms, and the answer will end with an exponent probably between 10 to the 21st and 10 to the 25th in your scientific notation. If you've got an exponent way outside of that range of about 21 or 25 for your power, then again, you've probably done something wrong. And then for moles, your answer will be between 0 and 100 if your unknown is moles. Moles can be a decimal, can have a negative exponent, that is allowed. Usually the answer is going to be less than 20 moles. It's possible to have a number of moles bigger than 20. It's unlikely. Okay. Let's talk about alarming answers. Answers that when you see them, it should make an alarm go off in your head. I've done something wrong. You should look at these answers and think, maybe I need to double check my work. Something here is not right. Starting with 12.01 times 10 to the 46th atoms. I'm just gonna real quick color all of these and then expand the page again. Just to make it easier for everybody to know what they're looking at. Okay. 1.201 times 10 to the 46 atoms. What are the warning signs here? Well, 10 to the 46, that exponent is way too big. For atoms, your exponent should be probably between 10 to the 21st and 10 to the 25th. You need it to be 10 to the 21st or 10 to the 25th, somewhere in there. So how could you fix it? Most likely what you have done is you have probably multiplied by Avogadro's number when you needed to divide by Avogadro's number. Now it's possible that you've done something else wild and weird that I've never seen before, but most likely you need to change to dividing by Avogadro's number. Like that's your key thing, is most likely you multiplied and you need to divide by Avogadro's number instead. Yeah, I should just leave it unexpanded. I keep switching colors. Okay. 1.201 times 10 to the 23rd moles. That's a problem. Your answer of moles should be between 0 and 10. Or sorry, 0 and 100. 10 to the 23rd is way, way, way bigger than 100. So there's two things you could do to fix it. First of all, check. Maybe you wrote moles and you should have written atoms. That's one thing. You might be using the wrong unit for your answer. Another option is you multiplied instead of dividing by Avogadro's number. You also might not even need Avogadro's number. Depending on the problem. Something to think about. There's more options on that one. 1.201 times 10 to the 23rd grams. Again, what's your warning sign? Grams should not be 10 to the 23rd. Grams should be between 0 and 600-ish. I'm going to abbreviate the word between. I hope that's okay. And 10 to the 23rd is way, 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 way bigger than 600. So, so again, you pretty much same thing in this box as the previous box. Either you wrote grams and you should have written atoms, or you should have possibly divided by 6.02 times 10 to the 23rd somewhere instead of multiplying, or you maybe shouldn't have used Avogadro's number at all. Okay, 1.201 times 10 to the negative 23 atoms. That warning sign is 10 to the negative 23. For atoms, the exponent should be positive only. You should not have a negative exponent for atoms specifically. So probably what you need to do is you probably divide it by 6.02 times 10 to the 23rd, and instead you need to multiply by 6.02 times 10 to the 23rd. That is almost definitely what went wrong. 1.201 atoms is a problem. Your warning sign is that atoms need scientific notation. If you have an answer of atoms without scientific notation, you are definitely doing something wrong, I guarantee. So there's two options here. First, you should check, did you write atoms, but instead it should be grams or moles? Because that's a possibility. Another option, did you leave off the scientific notation? Like check if it's in your calculator and you just forgot it. If your calculator has like an E at the end. So here, I should have, sorry, no, it's getting messy. See if your calculator has that capital E for engineering exponent at the end. And finally, 1.201 times 10 to the negative 4 grams. So, okay. Grams can have a negative exponent. They will usually be under 100. They can be between 0 and 600, and technically this is between 0 and 600, but this is probably too small. It's possible for this answer to be there, but it's unlikely. So really what I would say is you probably typoed something. You should check that, because this is like 0.000121, and that's like really small for a number of grams. So you probably typoed something would be my guess. Okay, a note, all of these comments we just said are regarding values of grams, atoms, and moles that we're going to encounter in this class. If you take another chemistry class later in high school, or if you take it in college, or if you grow up and work in a field in which you do chemistry daily, you could totally end up with numbers outside these ranges that we're talking about on this page. I'm just talking about, like, for the purposes of this class, what kinds of answers should alarm you. Now, I will say some answers should always be alarming, like 1.201 atoms, because you can't have 0.2 of an atom. That's not how counting works. Atoms don't come in decimals or fractions. So something to think about as you go through your quiz that's coming up.